Okay, so I actually had to run here because my train was late like 30 minutes, and I took the city bike, which thankfully had two wheels, and I could arrive here by the time, but it was a blast. Okay, so my name is Maciej Lasyk. I'm a software engineer, and I'm focused mainly on backend services and operating systems and that stuff. Okay, so as you can see, there are 65 slides, so we have to really hurry. This presentation is the first part. The second part, unfortunately, I will not show it here. The first is about history of Linux containers and Unix jails, etc. And the second one is a walkthrough, so maybe next time. Okay, so let's keep agenda and disclaimer. Why at all I created this presentation? Simply because there is so many container services and solutions right now that actually people can be lost. Docker this, Docker that, Kubernetes did and that, here and there, etc., etc. It's actually a very good idea to know what's the story behind all those containers before you start implementing those in your production services. Okay, so I have, as I said, many slides. There are quotes in those slides. I didn't always paste the specific source for that quote, so let's say that in the first two slides, this and the next one, there are sources for this presentation. So if something is quoted, means look for the source here. Okay, so what kind of problems containers should solve? There are actually 4 problems that I think about. Application environment isolation. Basically, if you, let's say, you are a Pythonist and you probably remember this pip problem with installing libraries and library dependencies. Actually, most of languages have problem with dependencies. So containers are to solve this. Resources isolation. When we have more than one service on one host, never mind if it is virtual machine on or a bare metal server, there may be a problem with race for the resources between those services, and containers should resolve that problem by allowing user to attach specified number of services, specific amount of resources to the service. Cross-platform compatibility, that's a no-brainer. We want to implement a service on Windows and run it on Mac and make it run exactly the same way as on Windows, let's say. And resource density, so when we have, for example, a virtual machine and we have like 8 gigs of RAM and our service utilizes only 1 gig of RAM, what about the rest 7 gigs? We pay for it, yeah? So when we put there more services in container environment, this should be good. What is a Linux container? Resource limits with cgroups, I will talk about it later. Security kind of separation. LSM stands for Linux. LSM is security module in Linux kernel. For the short, like SE Linux or AppArmor. Virtual separation. It's about namespaces. I will talk it later about that, and something to monitor container processes. So when we have a container, it would be good to make sure that it's running, and there should be something that is making sure that the container is running. Okay, so the history. Okay, so the year 1979, we have the first actual implementation in BSD. BSD stands for Berkeley Software Distribution, and it was about the first implementation of chroot. So actually the view of the file system for some process that is running beneath. It was actually provisioned 3 years later in 1982, and that's all about it. Hands up, who actually used chroot? Okay, maybe more hands up. Who is actually working in backend services somehow? Software engineer in backend services, DevOps engineer, Linux administrator, Okay, nice. So it's important for me because I have to know how to talk to you and how deep I can go. Okay, year 2000, so actually 17 years later, we have FreeBSD jails, and actually this great implementation because it takes care of networking, it takes care of storage, resources, isolation, etc. But it wasn't Linux, it was FreeBSD. Linux vServer 1 year later. This project is now dead, unfortunately, but this was one of the first implementation on Linux. Problem with that was that it was actually, you needed to patch the kernel to make it work, and it wasn't at all simple. Mind the year 2001, so no Ubuntu, no Fedora back then. Probably Slackware or Red Hat Enterprise Linux v1 or something, or even Red Hat Linux. So yeah. Actually, when I was in that train today, I rechecked, and the latest stable release one was in 2008. But there is some release from this year, which is a preview release. Still, it was closed because there is one developer behind that. I mean, not closed, but it's not in the upstream anymore. Okay, so in 2002, there was this document published. I found it on Web Archive. One of the first documents, how to chroot on Linux, and that's very important because it is a starting point for the next slide. Guy was from France, as well as many other things happened in France. You will see it later. Okay, so 1 year later, Linux jails for money, I called it. Basically, company behind that implemented this chroot on Linux and started selling virtual boxes, let's say. Per C, Python, you could run ERC there, etc., etc. Again, France. Okay, later, Solaris Containers. Who actually used Solaris here? Oh, I love you guys. Okay, so Solaris, owned by Sun Microsystems, actually created these containers. It is like zones. The great thing behind that is it has a deep integration with ZFS, which is a storage system. This deep integration, by this I mean that actually one container doesn't have any possibility to enter another container's storage, no matter what happens. If the process gets out of this container, it actually can't. It is by design, and still in our current year 2018, we don't have this kind of integration in Linux. Maybe if you would use ZFS on Linux, no. Even not, because still there is no such implementation in a container engine. So yeah, okay. Later, OpenVZ Virtuoso. Let's skip that. It was a closed implementation, but it was. I just wanted to put it here. And 2006, the very important thing, Googlers implemented the cgroups thing. Cgroups is a utility in Linux kernel that gives you possibility to for creating resource isolations and applying some amount of resources to processes like memory, like CPUs, like I/O resources, etc. Thanks to that, right now we can apply. I mean, we can assign, let's say, 2 gigs of RAM to particular Linux process, or say you have to. You can actually use at least 1 gigs, or you can use 8 gigs max. Okay, and the 2008 is very important for Linux because of LXC. LXC is actually the first implementation that didn't need any kernel patches because it used Linux namespaces, which is provided by Linux kernel. And that's all for the starters. As I remember, there was no cgroups in the very beginning, but later, yes. It was created in C with wrappers in Python and shell. So basically, the libraries were created in C, and the wrappers, the scripts for administrators, were created in shell and Python. And it was huge, because as you will see, most of the later implementation of containers used that. What happened here is that LXC, by using namespaces, created a view of file system, created a view of PIDs, and created a view of users. Yeah, probably. Not sure if it used user namespace. Probably not, because it wasn't back then implemented, so no. Okay. Okay, and 1 year later, the first company who actually used LXC was DotCloud, the company that will be later behind Docker. And why it's so important? First, because again, it's French, so stop talking that French is always surrendering. French stand behind the containers in Linux, as you can see. I'm not from France, by the way. Okay, so they had their proprietary solution called DC, and they used LXC behind for creating containers, and they sold the virtual boxes, called them somehow, whatever. They also used the AUFS for copy and write, and that's very important, because there was not no one before used the AUFS for that before, and they created container repository, so they could pull and push images, etc., something what we have right now in Docker. Yeah, and they had the problem of networking solved somehow. Can't tell how, because it's closed, so we didn't see the sources. And yeah, you could start, stop, etc., and manage containers with LXC. Moreover, they could expose ports, like Docker do right now. Cloudlets by Solomon Hykes, who is the guy behind Docker, were the universal server images. So basically, guys wasn't interested in giving users possibility to run CentOS or Ubuntu or whatever. They wanted to give them possibility to run WordPresses, etc. And so the end users didn't care about what kind of operating system is behind. They just wanted to service. That's why Solomon Hykes created the cloudlets as for the universal images. Okay, later, yeah, this is a huge date. Oracle bought some microsystems and closed Solaris, so no more open Solaris. This is the date when some people from Sun Oracle jumped out and I mean left Oracle, forked Solaris, called it Illumos, with Brian Country, as I remember. Okay, 2011, Warden. Cloud Foundry started Warden. It's some else service, proprietary service that was selling virtual resources, whatever is LXC, etc. This is quite interesting stuff. 2011, it's the date when SystemVN Spawn was created by Lennart Petering. Actually, in that very year, I met Lennart for the very first time in Prague during the LinuxCon conference. And I was talking to him about this very nspawn solution. I was very interested in that, but I didn't get it running because problems with compilation of systemd back then for me were yeah, I just couldn't do that. Okay, so what is this about? Lennart Petering, he is the guy, one of those guys behind systemd. Who doesn't know systemd here? Okay, so I will not explain what it is. Thing behind nspawn was that Lennart, while implementing systemd, while developing it, he had problem because every time he wanted to test the boot process, he would have to restart the machine, the virtual machine, and it took 30, 90, 60 seconds, 120, etc. So he implemented something called nspawn, and it was a minimal implementation of Linux containers, that just to make sure that he can, under this Linux container, test the boot process in like 1 or 2 seconds, and he did that. It was created with the idea of full OS inside. It was very low level and still is quite low level. Yeah, and here's the presentation, one of those from Lennart Petering describing how it works. Whoa, okay, 2012 or 13. I was to tell you in the very beginning, don't read the slides. It's just so you can later read it again. Just listen to me, don't read. This is the first presentation about history of something I am giving, and that was why I thought that putting all the text here will be good, because you will be able to read it afterwards in details. So don't read it, please. Okay, so what's important here? Actually, this is a business case. This is a business slide. DotCloud had some problems. They had a couple of thousand of customers, but they weren't earning so much money that they could stay on top, let's say. There was Salesforce, there was Cloud Foundry with Pivotal back then, and some other PaaS services. And what I didn't tell you was that the main DotCloud service was actually the PaaS service, and the PaaS business is very hard. They had to fire a couple of guys because they didn't have enough money to run the whole company, and they didn't have idea what to do next. Actually, they did have. They thought that maybe instead of selling PaaS services, they will open source the DC somehow, and then people will start using it, and they will change the business model around it. So they did. They prepared DC for open sourcing, called it Docker, and pushed it to people. Yeah, and in the business books, probably this will be described as one of the very successful pivots. Okay, why did Docker work in the very beginning? User, Docker engine with all the magic and the Linux containers, and that's the stuff. So everything happens here. If this is being restarted, this is being restarted. If this hangs, this hangs. Yeah, basically that. Docker engine does everything. And one more thing about DotCloud. What happened to DotCloud afterwards? DotCloud, separated from Docker, was acquired by Cloud Control, which got bankrupt 1 year later. But before that bankruptcy, it was acquired by Exascale, which closed the DotCloud service. So actually, this was the very, very last time that Docker could actually somehow get out of that. So thankfully, yeah. And they didn't surrender, as you can see. Okay, 2013, not that important, but let me container that for you was created by Googlers again. They had already in mind the thing called Kubernetes. In 2013, they started talking about it, and let me container that for you was a very low-level implementation of container service. Who of you actually compiled Gentoo in your story somehow, someday? Okay, so I'm asking you because using let me container that for you reminded me of compiling Gentoo from the first step. It was like pain in the ass, really. Yeah. But you can still try to use it. Okay, Lipcity is just information that there was such a thing. And for me, it's important because it was the first thing beside LXC, and let me container that for you, that was not using LXC. Created in C, and all the interfaces were in the C library, and that's all. End of story. Okay, libviz LXC. This is the story of actually RedHat and how RedHat run things. RedHat, as you probably know, in RedHat 6 had this 2.6 to 0.32 kernel, which is like 10 years old right now. And all the new features required by, for instance, Docker were backported to that very kernel, which is a very hard thing. One thing that they couldn't do with Docker, and they wanted Docker in enterprise, was having LXC in RedHat kernel. So what they thought about how to solve that. Let's make Docker daemon pluggable, and when it is pluggable, instead of this one Docker daemon, let's create plugin called libvirt-lxc. As you know, libvirt is in RedHat for KVM, etc., etc. So maybe for LXC we could create some plugin with that. And yeah, Dan Walsh's team back then with Docker guys, they created this lib container thing and put that libvirt-lxc, and that is exactly how Docker was running in the RedHat for a short while. Actually, I have one server running this version up to this day. Don't ask me why, it's convenient. Okay, smartos from Joyent. Joyent is this company where Brian Cantrill actually works. Who knows Brian Cantrill? Ah, guys. Okay, so there will be slide with his videos. Do watch his videos. He's got really lovely rants and he's very smart guy. Okay, so Joyent created smartos based on this Illumos, so Solaris, let's say, with containers, those, etc., etc. They had dtrace, which is fine for all the system administrators, and what's very important, and it's fun, they actually use this LX something project to implement Linux syscall stable and put it in top of Illumos, so they could actually run Docker there. There is 2 or 3 presentations by Brian Cantrill who described that. You can watch them because it's not exactly that it was implemented on top of kernel in Illumos. It was put it somehow, and it's very complicated. Okay, 2014 lib container. Actually, the thing behind that is it's the first OCI runtime, not called an OCI back then, because there was no OCI back then. OCI stands for Open Container Initiative. So actually, it was the first runtime to run containers. What's a container runtime? When we have this Docker engine here and container here, so between there is this container runtime, and this is the first time actually that Docker engine was split into two parts. It's very important for later you will see why. Also in 2014 Coreos started, and it was something completely different than Docker. Also different in terms of how it was implemented. There was firstly there was a specification created called APSI, and when this specification was created, afterwards it was implemented. And thanks for that specification, there was even a BSD implementation called Jetpack. And it's just for you to know that it was there. This project is dead for a couple of years now. Okay, Kubernetes. In 2030, there was the story behind Kubernetes. It's actually the story behind Google. First of all, read this one because it's very interesting description why and how, etc. Short story is that Googlers have this Borg service. Actually, Borg is a resource manager. They run inside and they don't really tell how it runs. And it is something that was before Kubernetes. Kubernetes was based on their experiences on Borg. Actually, oh yeah, why this name? The Project 7. Do you watch Star Trek? Yes? Okay, so the name of Kubernetes. Borg, I got a couple of friends in Google, and some of them told me that Borg is not that easy to run and it's not that reliable, but it's great. Nothing better is out there. So the codename Project 7 was taken from Star Trek, and it is about these nicer Borgs, and that is why. Also, Kubernetes logo has these 7 lines around, so that's there. Yeah, and initially Kubernetes was running Docker engine inside, and it was probably a pain in the ass to run that. I mean, I know that, but whatever. Okay, GCE in GCP, Google Container Engine in Google Cloud Platform. It was just after the Kubernetes was released, and it was firstly in alpha. 1 year later, it was in beta and came generally available, meaning stable. Kubernetes 0.4 something for the alpha release, and it was with this Docker engine. LXD. Okay, so Canonical was behind that, and LXD is not a fork of LXC like you can read in internet. It's just a wrapper around LXC. It uses LXC beneath, but it gives you nice UI. It gives you even more nicer CLI tools, and that's the story behind LXD. I like using LXD when I'm on Ubuntu, let's say, because LXD and LXC give you this full-blown operating system beneath. You can run SSH, you can run any number of services, not like in Docker, which was created for running just one process, remember that. Okay, a friend of mine from Cracow, Grzesiek Nosek, he actually implemented ThruBox. Why I put this slide here? Just to show you how easy it is to actually implement your own containers in Python. You can check his repository and try to do it right now. It's even easier for you now because you've got specifications for how Linux containers should work. So yeah, just try, and if you are really interested of how container works, try to implement those by yourself in Python or Go or whatever. Okay, 2015. Let's check the time. Oh. You have to hurry. Okay, CNCF OCI. So this CNCF stands for Cloud Native Computing Foundation, and it was created by the huge companies like Google, like RedHat, like IBM probably, etc., etc. Yeah. So the story is that there was a huge amount of movement around containers, and there was this Docker, and there was this Rocket from coreos, and those big companies, they wanted to have a piece of that cake because there are huge money behind, as you probably know. So they created this foundation, which was put under the Linux Foundation back then, and with the goal of telling how containers should work, and with the goal of cutting containers, Docker containers for instance, into smaller pieces. So actually all the parts of the Docker engine could be replaced by something else. So actually let's take Docker from Docker ENC and create something else, and let's say a replacement created by us in RedHat or Google or whatever. Google actually donated Kubernetes as the seed technology here, and also RunC, which was the first OCI runtime, was donated by guys from RedHat and Docker. Okay. In the very same time, 2015, there was this first implementation of container runtime interface called containerd. So basically, when this was implemented, finally, probably in version 1.11 of the Docker, you could restart Docker engine without having containers restarted, because there was a daemon, but it wasn't. It was no more the client. It wasn't tightly coupled with each other. There was this Docker container shim that was using RunC to create containers, but actually after the container was created, it wasn't attached to Docker daemon anymore. Funny story is that in the very first stable implementation, after that we ran in Cracow the Docker meetup event, and one of us, Maciej Lasyk, he ran a very quick demo how it works. So he restarted the Docker daemon, and what happened? All the containers also restarted. Okay, so it wasn't the way like it should be, but yeah. Okay, Kubernetes CRI, Kubernetes Container RAM Interface. The only important thing from all these is that in 2016, in the Kubernetes, the container management was actually taken off from the kubelet. And that's what you need to remember from this slide. Thanks to the container D, because it was just split out of the container engine. And in the very same year, there started, I mean, problems were always there in the line of between RedHat and Google and Docker. It was about the way how Docker was implemented, the way how RedHat would like to have it implemented, the way how Google saw it, etc., etc. So one of the main problems, like I told you, was that the RedHat kernel was 2.6.32, and backporting all the features from the newest kernels weren't always possible. And okay, just about this slide. Jessie Frazel, who knows her? Okay, so she's very smart woman, very smart software engineer. I like her presentations and I really like her work. But actually I hate this one. I say no to systemd specific PRs. It's her, it's what she typed in her DockerCon badge. Okay, and why did she do that? Problems between RedHat and Docker. Solomon Hykes had completely different conception of how Linux containers should work from, let's say, Leonard Petering. They couldn't agree. Dan Walsh, who was the leader behind the SE Linux, but started moving towards running containers projects in RedHat, had problems with running and implementing SE Linux policies that could run on Red Hat Enterprise for Docker specifically, and for systemd. There is a presentation about that. So the container security team, meaning Dan Walsh and others, couldn't move forward. Container stability, it's the thing that I even talked about with guys from Google here in Google Warsaw. I asked them during some cloud event how they actually manage, do they have any problems with managing containers, Docker containers in the Kubernetes, in this managed Kubernetes in a Google Cloud Platform. They couldn't tell me that openly, so I don't have details, but what I knew from them was that they have some wrappers to restart the Docker engine and to make sure that Docker engine is working perfectly, how it should be, and it's not easy task. So, how many of you had problems with container stability using Docker services? Okay, and how many of you use Docker services on production? Okay, that's nice. So, yeah, probably because only 2 people actually raised their hand for the first question, and like 15 people raised their hand for the second question. So, no problems on production right now. But maybe because it's 2018 and Docker currently ranks really good. I have to say that, and I like this. Okay, so what happened about these Red Hat problems, etc.? Googlers and Red Hat actually forked Docker. Later it was called Cryo. And this was a very important moment because forking Docker was like telling, okay, we are not using your Docker anymore, we are doing our way. And we're gonna replace this Docker with something else in the future. We're gonna split it apart, and that's all. And yeah, okay. 2015 Garden, replacement for Warden, written in Golang. It was from Pivotal. Why this slide? Because it was created for different platforms. And it wasn't Docker based, so it's interesting stuff. It was using the RunC. Okay, oh yeah, ECS in AWS Services was created and published in 2015. Also in Azure, they have this Azure Container Service. What's important here is that they didn't use only Docker, but also Mesosphere. Are we, Janusz, we are going to 12? We are finishing on 12? Ah. Okay. 2016, Skopeo. So RedHat has this project called Project Atomic. It was like project for creating some container manager to run some virtual machines and maybe sell it in the future. The important thing behind Project Atomic was that they had many sub-projects, and so many of them are used right now within Cryo, you will see. The first of those was Skopeo. What's the story behind that? Dan Walsh had this problem that he couldn't actually, I'm telling he that because I heard this very story from him personally, that he couldn't basically download this config.json file from the remote repository of container images and just see what's inside, because he wasn't sure if he can download it, if he should download it or not. And the problem is that actually this image is like 2 gigs or 3 gigs. So you have to download 3 gigs just to see that in config.json it's not what you are thinking about, and then you have to trash it and take next and take next. So some other guy created this Skopeo project, some other guy from Dan's team. And this project's goal was to actually replace the part managing Docker images in the host. So thanks to Project Skopeo, you could pull push, you could just view all the metadata without downloading the image. Later you could also commit, and also it supports more than only OCI image. It supports also tars, plain tars, etc., etc. So it's a nice project. What happens in the Solaris world, let's say? Joint created Smart Data Center, which is actually their product they sell with smartos beneath. The interesting stuff here is that they use Docker and they run Docker containers on top of bare metal servers. And it's fully automated and it's very nice. See Brian Carter slides. This is the URL. Early. Not slides, videos. Okay. 2017, this is important because there were these 2 specifications created, and those 2 specifications tells you exactly how image should look like and work, how its layout should look like, how should look like file system layers, etc. And the runtime specification for all the for free platforms, not all, how containers should be created, run, etc., etc. So basically, if you would like to create your own containers, implement those, you start here. Okay, Cryo. Cryo is the idea of RedHat to replace Docker engine in Kubernetes. You are from RedHat? Okay, sorry, I'm asking because you smiled, and this telling that RedHat would like to replace Google in the Cryo, not the best idea. Okay. Yeah, so basically this is the story. Let's split Docker engine in more pieces, and then we can replace this piece by piece and have this Cryo inside. Okay, let's skip to the next slide. So how would Kubernetes work right now? This is whatever. Not this resolution, sorry. Okay, so here we've got, let's say, Kubernetes, and there's the kubelet, so this is the magic place where everything happens. And when you say to Kubernetes, okay, let's deploy me Nginx server, I would like this kind of deployment. Then the kubelet actually asks Cryo, this is Cryo, through the gRPC to run Nginx. And Cryo finds this OCI image in this image service. This image is pulled down somewhere from here from the internet or from here from the internal network. And then basically the Cryo unpacks this container image somewhere in storage, let's say like here, and from that storage RunC, through the RunC container is created. What's important in Cryo is that Conmon is the service that it's the process that actually makes sure that container is running, that it has TTY attached, that it has logging enabled, and the logs doesn't disappear or do disappear if someone wants them to disappear, etc., etc. What happened to the Docker? Docker was renamed Moby. When Cryo was when Googlers and RedHat forked Docker and created this Cryo, the move of Docker was to rename the project and also split it into pieces. It was actually already done, and give clients possibility to replace those pieces like they only want. So they actually wrote that from now on, Moby is a framework in which you've got all the parts, like containerd, like runc, etc., and many more parts, all the parts that you need to run your own Docker orchestration, container orchestration, sorry. But Moby is recommended for anyone who wants to assemble for hackers, system engineers, infrastructure providers, etc., etc. But Moby is not recommended for whom? For enterprise and for application developers. And that's basically, I mean, why this? Because companies for whom we work, generally, let's say, not Googlers, not Red Hatters, etc., but companies who sells like virtual machines or who sells internet, online shops or whatever, they do money from selling services, not from creating container engines. That's one of the general problems during last 3 years. Companies really focus on creating somehow container engines that they could apply in their services. But why do that if you have actually this already implemented? So don't use Moby for creating your own container engine just for your company being able to run some online service, an online shop or whatever, because it's not created for that. Use, I don't know, Cryo instead, or LXD, or SystemVN Spawn. Okay, SystemVN Spawn is not a good idea because it's also very low level. Buildup, another sub-project from Project Atomic. The main idea behind Buildup is about creating creating container images with possibility to use the Docker file, but also bash. Because why not use bash during creation container image? Why use Docker file? What's the idea behind that? I mean, I know not everyone should use bash because sometimes it's just you've seen probably very wrong implementations in bash. That's why Docker file is trying to solve that problem of whatever. Okay, it has support for non-root builds. It's Docker drop-in replacement for Docker build, and that's the story behind that. Azure, it's moved from ACS to AKS, meaning that they started Kubernetes service. And in 2018, we have also OCI Distribution specification. Distribution doesn't stand for Linux distribution, it stands for how we should distribute images. So how to create a remote repository, how to verify images, push and pull those, etc. And in 2018, actually, SystemVN Spawn had OCI Runtime implemented by Leonard. It's not merged currently, but probably it will be. In 2018, also RedHat acquired CoreOS, and also they created. Why they acquired CoreOS? Do you have an idea? CoreOS is still, or was, the first of the second distribution used on AWS Services. RedHat needed the name because they wanted to sell their Cryo in the future, but they couldn't sell it under the name of RedHat Enterprise because they still have this 2.6, 2.32 kernel, and you can't run Cryo on that kernel. I mean, it's not that simple. Plus, they earn money from Red Hat Enterprise, and this is one business model, and the second business model is about Kubernetes and Cryo. Those are two different things. So let's buy CoreOS, let's dump Rockets and all this stuff, let's replace it with our Cryo, and it's gonna sell. Okay, Podman. It's a drop-in replacement for Docker, let's say. There was this presentation by Dan Walsh. It was very funny about what Podman is. First slide, dnf/yum/apt-get install Podman. Second slide, alias Docker equals Podman. Finished. Do you have any questions? It's what Podman is for. So basically, this is the container interface, just another from Docker engine, and it may be used for creating non-root containers, for creating containers that don't have any daemon running behind. So basically, Podman, when it starts container, it's completely split from any other processes. It's just a running process in Linux. If you use Linux on your laptop, you can basically install it and run it. It's a very nice thing. Okay, so AKS in AWS Services, so Kubernetes in AWS Services also in this year, systemd portable services. This is nice stuff. Do read about that, but we don't have time for that, sorry. And yeah, why IBM acquired Red Hat? And again, any ideas? I mean, it's just what I think. They do need something. The IBM bought Softlayer a couple of years ago. They came into this virtual machine and selling virtual machines, etc., but they don't have anything in terms of Kubernetes. I mean, they have some service, but it's not selling very good, and it sucks. So I don't know, maybe someone told them, let's do something with Kubernetes, and someone told them, let's buy some Red Hat enterprises, and someone didn't understand and they bought Red Hat, I don't know. Okay, this really, I mean, in 2010, this was this Sun that was acquired by Oracle, and now this. But IBM is not Oracle. Like really, like I hate Oracle and IBM. I read about that on their webpage, so you know. But they are behind some open source, well-known services for years, and they put huge amount of monies to open source. So maybe it's not gonna be that bad, or it's gonna be better. So I hope. What next with Red Hat? Coreos will die, Atomic Host will die because there is no point for running this anymore. Enterprise can't be changed. Actually, it can, because Red Hat Enterprise 8 is in alpha right now, and it has really new kernel, so I'm not sure about that. And yeah, we've got Red Hat CoreOS with OpenShift, which is running Kubernetes underneath with Cryo, and is actually Red Hat CoreOS by IBM right now. Okay, so I think that's all for now. You know what a Linux container is already. Runtimes that are available right now, Cryo, Containerd, Alibaba Pouch is very funny thing. You can read about that. And this is something from the very east. And in these very old kernels, they import from Rancy, Docker, P2P, torrent backend, etc. And even exposes Cryo sockets. There is a great presentation from All System Go conference this year by Vincent Batz. Please do watch it if you want to hear about these container runtimes. OCR runtimes without Rancy here, nspawn OCI, lib container, etc., etc. Okay, and remember that we've got 3 specifications right now. Third one is not generally available. I mean, it's not released. Okay, part 2 OCI walkthrough maybe another time. Thank you.